So first of all, let's start with a definition here, right? And I'm going to start really basic. I'm going to build up slightly technical as we go. Computer vision ultimately is the combination of cameras as the input device, artificial intelligence to process those cameras, and then the insights that you gain out of that. And those insights can be real time, like, hey, something happened right now, I need to take some action right now. Or they can be kind of over time. Hey, this is the average of something, or this is how frequently something happens, or this is how much time this normally takes, right? So there's kind of two different buckets of insights you might gain. But the AI part is what's interesting. It's what makes computer vision different. Think about what a human does, right? A human, hilariously, the eye and brain are switched in the diagram, but the human brain, the human eye sees the forklift, the brain processes it, and you comprehend quickly that that's a forklift. Well, this is the same idea. The camera sees the forklift. A neural network identifies that it's a forklift and not a box or a person or a car or a truck. And we get the same result. So we're trying to think like humans think. And in fact, the way computer vision works is using deep neural networks. And these networks are essentially a bunch of neurons, the same kind of things that are in your brain, right? And so think about here on the input side, we have a bunch of pixels, the camera's actual data. Goes through a bunch of these interconnected neurons, and out the other side comes a classification. That's a forklift, that's a person, that's a box, that's a truck, right? That's a loading bay door, whatever it might be. What happens in the middle, funny enough, even to the most scientific of us, is a bit of a mystery. So there are algorithms and methods we use to train this network. And what that means is we adjust the weights and biases of how these connections are made, which is exactly what your brain does with neurons. The way your neurons are wired together define your personality, they define the intelligence, they define how you store memories, they define all these things about you, and they make you able to speak and see. So we're trying to emulate that same behavior in a digital world. And frankly, just like the human brain, how those connections are formed is we can only influence them a little bit. And we let those connections get formed, and we really test the outcome. So we keep training this network with more images, more data, until we like the way it performs. We don't get super concerned about the connections that get formed in the middle because frankly, just like the human brain, it gets out of control really fast. There's a lot of connections by the time you've built out one of these networks, right? This is a grossly oversimplified, imagine like 50 of these layers and thousands of these neurons, in each layer. So that's what's happening in that kind of AI portion. Here's the problem with that. It makes computer vision pretty complex. This whole process of training, understanding how to train them, how to optimize the models, then how to deploy them and make sense of them is all pretty advanced. And it really, for the longest time, was only used by the tech giants. So, Google and Microsoft and Apple and all those guys, they've been using this stuff, for a decade now, right? And that's how your phone can identify people in pictures and do things like remove the background, and all those things are using these same approaches. But it was very hard to bring this technology into the enterprise or into the small and medium business to say, we're going to use this work that's been done by the giant tech companies. We're going to take this research that's been done in academia. We're going to apply it to a use case in an everyday manufacturing environment or an everyday warehousing environment. Because, it's unrealistic to expect that you're going to go figure this out and hire people to go do this work. It's a huge R&D effort. So take that on one side, is you've got this kind of complex technology, probably pretty hard to adopt. And on the other side, the opportunity to use the technology is really large, right? And that's going to be what the dichotomy is this is hard to use, but it's very useful. And then hopefully at the end, I'll show you how to combine those things together. So let me talk you through the kinds of things in a manufacturing environment that you could do with this technology. So there's going to be three categories, and I'm going to show you a video of each one. This first category is about optimizing processes. So how do we make something more efficient, right? We've got customers, for example, that are monitoring assembly lines, and not way down to line level, but kind of like zoom out, kind of think about like a room level view. And they're looking at these goods coming down the line and understanding more about their own process. For example, and I'll show you a real world example of what that means in a second. In the case of the customer I'm going to show you, they're concerned with microstops. They have these bad events that happen on the line where things are bundled inappropriately, and it causes these short stoppages of the line. And for them, that's a big cost problem. You can also use it to do things like measure performance. Another customer is having us measure how long workers spend at various tasks to try to understand where there's time wasted or where there's a difference maybe between shift A and shift B, right, on a certain task. So here's a kind of a real world example. This is from a real use case. And it's coming down this assembly line, and we're seeing kind of a zoomed in view here, but if you zoomed out, there's like 4 different lines here that kind of merge together around this point. And so what you're seeing is, first of all, we're tracking which conveyor each bundle came from. So we know the origin. Because what happens is when something goes wrong, we actually want to be able to work upstream and understand, like, where did this come from? Which of the other lines caused this problem? And then secondly, we're measuring the linearity. So we're measuring, are these bundles in a straight line, or are they kind of like they call this a banana pack? Like, did it get over bundled, over squeezed, and kind of folded in on itself and became a triangle? That banana pack right there is going to cause this line to stop in a few minutes. And so for this customer, it's identifying that banana pack and understanding where it came from, and getting someone to do something about it before it gets to the device that's going to jam up on it. So I'll show you what that looks like in video form. Here's the actual line, and you can see kind of an understanding of how straight each item is, and tracking that object as it moves. Notice that we understand here that it's the same object moving, which again, to you as a human, is a really intuitive thing to do. Like if I pick up any object, this thing here, and I move it, you're not confused that this is the same object, even though I'm moving it around. But for computers, that's a big deal, because computers look at these images one image at a time. So for us to understand that that's not another cup, but the same cup, that's the kind of work that you have to really put into these solutions to get them to do things that are useful. So let's move on to the second category. The second category is safety. And frankly, I think I've seen the most engagement here from manufacturing customers. This is to say, how do we ensure compliance with whatever safety systems and protocols we have in place, right? Generally as a secondary control. So we wouldn't propose today to use this technology as a primary control in something that's super dangerous. But maybe you want to do things like monitor PPE compliance. Are workers wearing the right PPE in the right places at the right time? So this can be done in a contextual fashion. It doesn't have to just be a hard rule, right? It can be based on, if the machine over here is on, then this area must have this kind of PPE, right? So it's the ability to do that with context, a way a human supervisor might do it, not just kind of a hard set rule about what's required. Here again, you could make these into like real-time actions. So you could say, hey, this thing is so dangerous, I'm going to sound an alarm. I'm going to text the manager. I'm going to do something right now. Or you could say, hey, I just want to monitor how good our compliance is, so that we can put that up on the board and we can set a target and try to improve our compliance for the team. Right? So this is sort of an alternate to the days since last accident metric. Right? Instead of that, it's what's our compliance rate with the safety protocol, and how do we push that number up? So here's an example of that kind of environment, right? This is a paper mill, and you've got this worker at the top, not wearing, this machine is clearly on, and looks like it's moving pretty fast. And you've got this worker at the top who's basically got his fingers in it, and he's not wearing any protective gear, and he's on the second floor, and like there's just all kinds of things happening here that look suspect. And so maybe that is an unsafe condition, and maybe it's been going on for 5 minutes or so. Whereas over here, you've got somebody, you can't really see it, but they're just pushing like a cart with something in it, and they're not in an area particularly dangerous, and they don't need PPE. And so that person, even though they're not wearing any PPE, they're fine, right? So it's that contextualization that really matters here. So this is a example that we just filmed literally outside of our office. Our offices are in Irvine, so we're local. And you can see here what's happening is this is a safety area we've defined, and the folks that are blue outlined are not in the safety area, so we don't really care what they're wearing. In a minute here, you're going to see somebody, the gentleman on the right, he's right there. He's going to walk into this safety area, and he's only wearing a vest and not a hard hat. So he's partially compliant, so that's yellow in this example. And then the other gentleman that walked in is not wearing any safety gear, so he's red. And when we put the hard hat on, now we're fully compliant, because that was the rules defined for this area, is that you need a safety vest and a hard hat, right? So the ability to do that, and to do that anywhere with any kind of condition and business rule, is what this technology enables in this safety space. And then I promised there'd be a third one. Here's kind of the third use case. This is around tracking flow, and I mean that in the broad sense. So the movement of people, the movement of goods. We've heard a lot of interest in monitoring loading areas, like docking bays, for how long did it take once the truck showed up for the load to start and finish. This is surprising to us, but apparently sometimes trucks pull up and they sit there, and nobody actually fills the truck, and you're wasting time. And so this could be alerting real time that a truck is ready to be loaded. It could be measuring on average how long it takes, both to start, to do the work, and for the truck to leave. It could be monitoring security in these areas. We have a customer that talked about stolen tires. They sell tires, and apparently what would happen in the warehouse is it'd be like 2 for you and 1 for me, and 2 for you and 1 for me kind of stuff was happening. And you could make sure that all the tires that are being loaded on the truck are actually getting onto the truck and not being pushed aside, right? So anything you could see with your eyes from a kind of security camera's vantage point, you could essentially start to understand, measure, monitor, and trigger off of. So I'll show you an animation here. This is a use case we've heard about a lot, which is forklift detection. And so this is, where are my forklifts and what are they doing and where are they going, and kind of heat mapping out the current and traditional paths the forklifts take. One of the use cases we've heard about a lot here is if there's aisleways that are too tight for 2 forklifts to be in at the same time, it'd be really nice to know which aisles are occupied and be able to show the other forklift operators this kind of real-time view where you're like, hey, don't bother, aisle 12 has got another forklift in it, go do something else before you go get jammed up. So you could use this to improve the flow overall, maybe change how you place items, just learn about how these goods and people are flowing through the space. So this stuff is real. Here you can see, this is some McKinsey research that says, 52% in 2019 and 41% in 2020 of manufacturing customers saw impact to cost by deploying this technology. So half of your competitors are using this technology in some way, and they're seeing a cost reduction, anywhere from sort of 5%, and it goes up to 20% in this chart. And then similarly, you're seeing increase in revenue as well, because if you can get that productivity up, if you can work on some of those efficiency use cases, you can actually have a revenue impact. And 71% are saying, 71 to 63% are saying they saw revenue impacts, starting from 5% and again up to 10% by deploying this technology. So it's pretty broadly deployed, but I think pretty concentrated today in the largest manufacturing operations where they have the R&D budget to go and do this work. Which brings me to kind of the final point. So how do you do this? Let's say you're bought in. Okay, great. I like the idea of using cameras. I want to use those cameras to gain insights. Maybe I have some safety stuff I want to do, or maybe I want to go track the flow of those forklifts. What would I do? How would I even identify the most interesting workloads? So I want to give you 4 things to think about on how to find interesting computer vision workloads. The easiest one is, where do you have cameras already, right? And think security cameras, not like sort of machine vision cameras on the line. Kind of zoom out and say, where do we have security cameras? Because whatever they can see, that's very low-hanging fruit. It's easy to take those camera feeds, put them into a platform like ours, and get the insights out the other side. So that's a good place to start. The second one is, where are you missing these metrics, this valuable business metric that you'd like to measure but can't measure? So like the folks that asked about the loading bays, they knew they had a problem with loading bays. They knew they weren't loading trucks fast enough, or the trucks were sitting idle too long. So it's a great place to say, okay, can a camera see that? Can I make that visible to a camera by installing a couple cameras? That's another good way to find these workloads. The third one is, anytime you see interactions between objects or between people and objects. So people too close to a forklift or to machinery, or people interacting with some widget or some machine, right? So the interactions are very interesting in this data. Is how do the interactions take place? How long? Was it safe? So that's another good place to think about things in your business. And then the last one is the safety stuff, which I think is just pretty obvious. Where in your operation do you have the most dangerous areas where people get hurt the most often? And if you had cameras that could monitor for compliance with those safety protocols, could you improve the safety culture in those areas? So I would look across these 4 dimensions to find these workloads. Now, once you find a workload, you have 4 options for how you're going to deploy the solution. Or 3 options, I can count. The first option is you go build it yourself. We don't think that's realistic for most folks. This is, again, going back to what I started with at the beginning. These are technologies that are still pretty academic in nature, and lots of R&D is involved in kind of getting them up and getting them working. The second option is what I'm calling single-purpose products. There are players in the space, there may even be some here, that are solving these problems for one use case. So like safety is a good example, where you could pretty well define that use case in a way that applies to everybody, and you could go deploy cameras and software and hardware to do the safety piece I've talked about earlier. But we took a different approach entirely, and we said, what if we could give a platform to customers that lets them essentially drag and drop and build these use cases kind of in this low-code environment, which lets you think about it like using Excel, but for your camera feeds, right? That's kind of what we have built. And so that's where we come in. And our platform is called Kibsi. Our goal is to take those camera feeds and turn them into this data that you can then action on, learn from, do something with. And I don't want to make this a commercial. I'm just going to give you a couple of slides on how that works. So you can see Kibsi here. That's our actual UI. It's drag and drop like this. You define the things you care about in your business in the terms that you care about them. You define interactions between them that you care about. That's what the lines are. And you then tell us when you want to trigger interesting alerts or metrics to be collected. And once you do that, you get all this stuff. You get kind of real-time dashboards that show you the stuff you were interested in collecting. You get the ability to take that data that's been collected over time and analyze it, take it into a platform of your choice and do more analysis. And you get those real-time alert event alerts. So if something happened that's so important that you want to be disrupted and notified, you get those. So kind of two steps. First, you define your model, what you want to do, and then you go and you deploy it and you get this kind of outcome. So the goal is essentially to bring this incredible technology that's being evolved and developed in academia, in big tech, and make it accessible to all of you so that you can do all these things at the bottom. You can measure your results, you can understand more about your environment, you can keep people safe. Thanks for your attention and for spending the morning with me. Enjoy the show.